Gentlemen, I'm going to present and I'm pleased to present this paper about the new sustainable technology for recycling returnable concrete in this first international conference on sustainable concrete. I will do the first part of my presentation dealing with the technical and fundamental aspects of the technology, and then I will leave the floor to Mr. Miyamoto, who will describe the implementation of this technology in Japan. Concrete, you know, is the second most commonly used material on the planet after water, and the production of concrete is globally huge. About 10,000 million cubic meters per year of concrete are produced. This means that huge amount of raw materials are used for aggregate and cement, and also a lot amount of wastes are produced. And among these wastes there is returnable concrete. Returnable concrete is the unset, unused concrete which returned by the truck mixer from the job site, that for any reason is not placed and comes back to the ready-mix plant. And in many cases, this material can be a waste with many impact on an environmental and economical point of view. In a conservative estimation, the global amount of returnable concrete globally is above 100 million tons per year. That means about more than double the amount of the total concrete production in Italy. And the new technology, with the new technology, returnable concrete is treated with a novel additive in the truck mixer, and it is transformed in a few minutes into a granular material that, after curing, can be used as aggregate for the production of new concrete. This technology has many advantages because it's characterized by high level of environmental protection, because no waste is produced. The concrete is completely transformed in a new material, and so no waste, no liquid, no solid are produced. Second advantage is that returnable concrete is fully valued because it's reused 100%, and this allows saving of natural aggregate, and so there is a protection of the natural resources. Then, from the economical point of view, 1 cubic meter of returnable concrete is transformed in aggregate. This means that about 2.3 tons of aggregate are produced from 1 cubic meter of concrete. And it's very easy to operate because it doesn't require any special equipment, because the process is operated directly inside the truck mixer, and it's very fast. The overall process takes about less than 10 minutes, and the additives are not based on dangerous substances or toxic chemicals. The novel additive consists of a superabsorbent polymer, part A, which is in water-soluble bag, and a component B, which is an ethylene forming compound that are added in sequence to returnable concrete directly to the truck mixer and mixed together. The typical dosage is 0.5 kilogram of part A and 6 kilogram of part B per 1 cubic meter of returnable concrete to be treated. The preferred order of addition may be first part A and then part B, or vice versa, first part B and then part A, according to the local condition. This means the type of cement, the water to cement ratio, and other variables. Both component A and B act to reduce the free water. So they have the capability to absorb or consume free water, and they act by different mechanisms. And water, cement, the filler, all the fine particles of the concrete coagulate onto the coarse aggregate as a result of the rotation of the drum of the track mixer. And consequently, the returned concrete is transformed in granular material, like this is an example. You see there is the coarse aggregate inside as a core, and around it there is all the fine material, water, including water and cement, coagulated on it. After that, the material is discharged on the ground and let harden as a normal cementitious material. And the day after, it is gently moved by an excavator in order to detach the individual grain, giving again the final aggregate. Once obtained the aggregates, it can be reused after some days for the production of new concrete. Of course, the characteristic of the new aggregate depends on the nature and size of original aggregates, the type and dosage of cement and the water to cement ratio, and the thickness of the coverage. The typical distribution of the new aggregate are represented in this graph. You see, this is the original, the distribution curve of the original aggregate in the returned concrete. And this is the typical distribution of the aggregate you obtain from returned concrete after the treatment. You see that you have a lower fraction of fine material, because the fine material coagulate onto the coarse aggregate, and so you have a lower amount of the fine fraction. Other physical and chemical characteristics of the new aggregate are a lower density, of course, because it's very similar to typical recycled aggregates, and higher water absorption. This is, of course, as a function of the particle size. And the component B is based on sulfate, and so the typical level of sulfate is increased compared to a natural aggregate without sulfate, with very low content of sulfate. By the way, the increase of sulfate content is not so high, and it is still quite below the technical standard, for instance, states by the European technical standard in Europe. And there is no increase of other components such as chloride. What are the performance of the concrete made by using these aggregates? So we made tests by substituting 30% of new aggregate in place of coarse natural aggregate. We use different cement, different Portland cement from 32.5 and 42.5, and different water to cement ratio according to the test we will do. And in all the concrete, the maximum aggregate diameter was 30 millimeters. You can see that there is no effect on compressive strength comparing the concrete made by the 30% substitution of new aggregate in place of natural one compared to the control. Control was a similar concrete but made with 100% natural aggregate. And also, durability tests were good. Particularly, water permeability was even better than the control concrete with natural aggregate. We are investigating deeply what are the reasons for this, and also the frost resistance was good, and chloride penetration too. Now I leave the floor to Mr. Miyamoto to continue the presentation about the application of the technology in Japan.
Good afternoon, ladies and gentlemen. My name is Mitsuya Miyamoto. I have the honor to represent GNN, a Japanese association of ready-mix concrete producers with over 45 RMC factories distributed all over Japan. The mission of GNN is improving concrete quality and sustainability through innovation by using new technologies and increasing recycling of materials. Today, the disposal of construction and demolition waste is becoming increasingly difficult and expensive. In Japan, the cost for disposing returned concrete is quite high, almost in all the prefectures. In the biggest cities like Tokyo, Osaka, and Yokohama, it can be up to 4,000 yen per cubic meters, equivalent to 30 euro per cubic meter. We started last year a co-research project to implement the new technology for returned concrete in Japan. This technology represents a revolution to the past because it does not produce waste, cuts the cost of disposal, contributes to preserve natural resources, and it is very easy and safe to apply. Today, more than 20 cubic meters of returned concrete are treated every day with the new technology in the Shizuoka, Yokohama, and Tokyo area, and its use is becoming increasingly popular all over Japan. It will soon really take off. The aggregates produced by the new technology have been tested by GNN in a wide range of conditions. For the production of non-structural, non-JIS concrete to be used in parking lots, graveyards, backfill, and road surfaces. We, together with other GNN members, discovered that it was possible to obtain excellent performing concrete by using 100% of the new aggregates in place of the natural one, 100%. After this discovery, new sustainable, high-performance, non-structural concrete material with 100% new aggregates was launched in Japan. In the next slide, I will show you some examples. Econ is a new concrete material based on 100% aggregates produced with a new technology. It has been developed by Nagaoka ready-mix concrete, and it is available in 6 different types, according to the class of strength and workability. As you can see, Econ produced in 6 different versions, depending on the requested strength and the slam value. Besides the excellent performance of Econ, thanks to its cheaper price, general contractor can save more than 30% cost. 30% cost compared to concrete produced with the natural aggregates. For this reason, Econ is becoming increasingly popular in the Shizuoka area, and over 500 cubic meters have been placed in less than 3 months. Now we are placing Econ more than 200 cubic meters a month. And then Neomix is an innovative concrete composition developed by Yoda Giichi Shoten, Sakuragaoka RMC, and Kaneko Concrete in Yokohama. It is 100% based on recycled materials, except for cement and bitumen. 100% aggregates produced with the new technology, 100% recycled sands, and sludges. Thanks to excellent performances and cheap price, Neomix is increasingly being used in the Yokohama and Tokyo area, and over 500 cubic meters have already been placed. Above 2 examples, Econ and Neomix, now we don't dispose returned concrete anymore. Actually, want it more, please give me returned concrete.
So, we finished with just 2 slides of the conclusion, but I think that we have explained quite well the fundamental of the application of the technology. Thank you so much.
We have time for one quick question. Do we have a question? No? Okay. Well, thank you, gentlemen. Very well done. I'm going to turn it over to Chair Satoshi.